Minash-shaytanir-rajim. Bismillahir-rahmanir-rahim. Today we are going to solve some problems related to using inverse Laplace transformation. So, example first is taken as log s plus 1 over s minus 1. Solution: let ft is equal to L inverse log s plus 1 over s minus 1. Hence, f bar s is equal to log s plus 1 over s minus 1. Then L T F T is equal to minus of d over ds f bar s. This is equal to minus of d over ds log s plus 1 minus log s minus 1. And just differentiating this, we get minus 1 by s plus 1 minus 1 by s minus 1. This is equal to minus s minus 1 minus s minus 1 over s square minus 1. So we get 2 over s square minus 1. Therefore, TFT is equal to 2 and 2 L inverse 1 over s square minus 1, which is equal to 2 sine hyperbolic t. Therefore, ft is equal to 2 by t sine hyperbolic t. Next one, find the inverse Laplace transform of s over s square minus a square whole square. Solution: we know that L sine hyperbolic at is equal to a over s square minus a square. Hence, L t sine hyperbolic at is equal to minus d over ds a over s square minus a square. This is equal to minus of a minus 1 2s over s square minus a square whole square. This is equal to 2as over s square minus a square whole square, implies L inverse s over s square minus a square whole square is equal to t sine hyperbolic at over 2a. Another example, find L inverse log 1 plus 1 over s square. So solution: let fs bar is equal to log 1 plus 1 over s square, which is equal to log s square plus 1 minus 2 log s. Therefore, d over ds is equal to fs bar is equal to 2 s over s square plus 1 minus 2 over s. Hence, L inverse d over ds fs bar is equal to L inverse 2 over s square plus 1 minus L inverse 2 over s. This is equal to 2 cos t minus 2. But T inverse L inverse but L inverse d over ds fs bar is equal to minus of t ft. Therefore, minus of t ft is equal to 2 cosine of t minus 2, implies ft is equal to 2 1 minus cosine t over t, which is a required solution. Second one, ft is equal to L inverse tan inverse s minus 1. Then fs bar is equal to tan inverse s minus 1. Therefore, d over ds fs bar is equal to 1 over s minus 1 whole square plus 1, implies L inverse d over ds fs bar is equal to L inverse 1 by s minus 1 whole square plus 1, which is equal to e to the power t sine t. But L inverse d over ds fs bar is equal to minus t ft is equal to e to the power t sine t, implies ft is equal to minus e to the power t sine t over t. This is the required answer. Now, another example, find L inverse s log s over under the root s square plus 1 plus cot inverse s. Solution: let L ft is equal to fs is equal to s log s over root under the root s square plus 1 plus cot inverse s. So f dash s is equal to 1 into log s plus s into 1 by s minus s over 2 into 2s over s square plus 1 minus 1 by 2 log s square plus 1 minus 1 by s square plus 1. This is equal to log s plus 1 minus s square over s square plus 1 minus 1 by 2 log s square plus 1 minus 1 by s square plus 1 is equal to log s minus 1 by 2 log s square plus 1 implies f double dash s is equal to 1 by s minus s over s square plus 1, and therefore L inverse f double dash s is equal to L inverse 1 by s minus L inverse s over s square plus 1, which is equal to 1 minus cosine of t. But L inverse double dash s is equal to minus 1 square t square ft implies t square ft is equal to 1 minus cosine t. So cosine f of t is equal to L inverse s log s over root s square plus 1 plus cot inverse s is equal to 1 minus cosine t over t square, which is the required answer. Now we are going to study about convolution theorem. So what is the convolution theorem? The function 0 to t f1u f2t minus u du is called the convolution of the functions f1 and f2 and is denoted by f1 star f2, and thus L f1 star f2 is equal to f1 s bar into f2 s bar. Also we can write L inverse f1 s bar into f2 s bar is equal to 0 to t f1u f2 t minus u du. This is equal to 0 to t f1 t minus u f2 u du. Now using convolution to find, there are two problems. First, L inverse 1 over s square plus a square whole square, and second one L inverse s over s square plus a square whole cube. Solution 1. Since L inverse 1 over s square plus a square is equal to 1 by a sine at, and using convolution we get L inverse 1 by s square plus a square whole square is equal to 1 L inverse 1 by s square plus a square into 1 by s square plus a square, which is equal to 0 to t 1 by a sine a u into 1 by a sine a t minus u du. This is equal to 1 by 2a square 0 to t cosine of a to u minus t minus cosine of a t du. Now after integrating we get 1 by 2a square 1 by 2a sine a to u minus t minus u cosine a t 0 to t. This is equal to 1 by 2a square 1 by 2a sine a t minus t cosine a t plus 1 by 2a sine a t. This is equal to 1 by 2a a cube sine of a t minus t a cosine of a t. Answer. This is the required answer. Now we are going to solve another question. L t over 2a sine a t. This is equal to s over s square plus a square whole square, and L sine at is equal to a over s square plus a square. So applying convolution theorem, we get is equal to 0 to t u over 2a sine au into 1 by a sine a t minus u du. After solving, 1 by 2a square 0 to t u sine au into sine a t minus u du. So 1 by 4 a square 0 to t u cosine of 2 a u minus a t minus cosine of a t du. Now separate two terms. 1 by 4 a square 0 to t u cosine 2 a u minus a t du minus 1 by 4 a square 0 to t u cosine of a t du. This is equal to 1 by 4 a square 4a square within the bracket u sine 2au minus at over 2a 0 to t minus 0 to t sine 2au minus of at over 2a du minus t square by 8a square cosine of at is equal to 1 by 4a square t over 2a sine of at plus 1 by 4a square cosine of 2au minus at 0 to t bracket close minus t square by 8a square cosine of at. This is equal to t over 8a cube sine of at plus 1 by 16a to the power 4 cosine of at minus cosine of at minus t square by 8a square cosine of at. So finally t over 8a cube sine of at minus at cosine of at. This is the required answer. Now next example, applying convolution theorem to find L inverse 1 by s root s plus 4, and second one 0 to t sine u cosine t minus u du. Solution. First, since L inverse 1 by s is equal to 1, L inverse 1 by root s is equal to t to the power minus 1 by 2 over gamma half. This is equal to 1 by root pi t. Therefore, L inverse 1 by root s plus 4 is equal to e to the power minus of 4t over under the root pi t. Therefore, by convolution theorem, we have L inverse 1 by s into 1 by root s plus 4 is equal to 0 to t e to the power minus of 4 u over root pi u into 1 du. This is equal to 1 by root pi. This root pi will come outside. 0 to t e to the power minus of 4u into u to the power minus half du. This is the required solution. By convolution theorem, we have 0 to t f1u f2t minus u du is equal to L inverse f1s f2s. Here f1u is equal to sine u and f2u is equal to cosine u, and f1s bar is equal to 1 by s square plus 1 and f2s bar is equal to s over s square plus 1. So 0 to t sine u into cosine t minus u du is equal to L inverse 1 by s square plus 1 into s over s square plus 1 is equal to L inverse s over s square plus 1 whole square. This is equal to 1 by 2 t sine t. This is the required answer. Now the next problem is use convolution theorem to evaluate the Laplace transform of first s square over s square plus omega square whole square, second 1 over s plus 1 s plus 2. Solution. First, L inverse s square over s square plus omega square whole square is equal to L inverse s over s square plus omega square into s over s square plus omega square. So this is equal to 0 to t cosine omega u into cosine omega t minus u du. This is equal to 1 by 2 0 to t cosine omega t plus cosine omega t minus 2u du. This is equal to 1 by 2 u cosine omega t minus 1 by 2 omega sine omega t minus 2u over the limit 0 to t. Now putting the limit, we get 1 by 2 t cosine omega t plus 1 by omega sine omega t. Another problem is L inverse 1 by s plus 1 into s plus 2 is equal to 0 to t e to the power minus of u e to the power minus of 2 t minus u du. This is equal to 0 to t e to the power u minus 2t du. This is equal to e to the power u minus 2t 0 to t is equal to e to the power minus of t minus e to the power minus of 2t. Next, L inverse 1 by s into 1 by s plus 1 s plus 2 is equal to 0 to t 1 minus e to the power of minus of t minus u minus e to the power minus of 2 t minus u du. Now separating the term, we get this and this, and in after integration we get e to the power minus of t minus u minus 1 by 2 e to the power minus of 2 t minus u 0 to t. This is equal to 1 minus 1 by 2 minus e to the power minus of t plus 1 by 2 e to the power minus of 2t. This is equal to 1 by 2 minus e to the power minus of t plus 1 by 2 e to the power minus of 2t. This is the required answer.